So why we have to go for this roll-up power electronics I-would system for hydrogen energy system? First, let me explain the importance of hydrogen energy. Then I will then and then in between I will explain the role of power electronics for water electrolyzer as well as fuel cell system, and importance of IoT for fuel cell operation remote side. So let me first explain the hydrogen system. Presently, we are using hydrocarbon-based energy system. Slide is not changing. So presently, our energy system is based on non-renewable energy system: coal, natural gas, oil. These are all the systems we are using for our electric mobility and the generation of electricity from coal. So these are all generating small amount of carbon to the major extent by pollution by vehicles, crude oil, petrol, diesel, creating huge amount of carbon dioxide, methane, and N2 nitric oxide for atmosphere. So we have to have a system which is non-polluting and also sustainable. For example, if you take the excessive coal, natural gas, oil is not polluting as well as it's not sustainable, or it will sustain for another 30-40 years. After that, we cannot recharge it. Crude oil, we cannot recharge it. Like if we exhaust water in the ground, we can recharge by rainwater. But we cannot recharge crude oil by any other way. So it's not sustainable. Also, it is polluting environment. So people are going for the renewable energy. So hydro is existing for many years, and the solar, wind, geothermal, tidal energy system for generating electricity. These are all renewable generating electricity. So we have been seeing this solar panels, windmill, geothermal is minimum in our country, but it is very famous in Iceland. And tidal energy, in a small extent, we are using this energy for electricity generation. These are all megawatt level energy generation, and it is distributed through the wires, electrical wires connected to the site. So what I'm going to discuss is the kilowatt level or watt level electricity generation for our mobility purpose. Onboard electricity generation. There is small amount of it, but whereas the hydro, solar, wind, geothermal is gigawatt level energy generation in a particular place. From the particular place, the electricity is distributed through the wires. Whereas in the case of fuel cell, it is onboard. You keep it in your vehicle. Wherever you're going, it's keep on generating electricity for mobility purpose. That is the beauty of this fuel cell. So in order to have this energy system in the vehicle for mobility purpose, we need hydrogen. The hydrogen is not available freely. It is like oxygen or hydrogen in the atmosphere. Hydrogen is not available, but it is available plenty in the form of water or hydrocarbon. If you extract again from hydrocarbon, either natural gas or other system, hydrocarbon system, again we are emitting carbon to the atmosphere. So it's not advisable to extract hydrogen from hydrocarbon sources. So better to have hydrogen extraction from the water source. So again, the water source, we need to spend huge amount of energy to separate out hydrogen from the water molecule H2O. But naturally, why the slide is not changing? Okay, it's okay. It's not about why we have to have this system, because if you see the vehicles, how much amount of carbon is emitted by the vehicle, 2-wheeler, 3-wheeler, 4-wheelers, and huge buses. Huge amount. For example, if we take bus, 1 kilometer, it is emitting nearly 1 kg, 800 gram of hydrogen, carbon dioxide to the atmosphere. That much, how much bus is running in India, you see. So this amount of hydrogen CO2 is emitted to the atmosphere. That is why we have to have a fuel cell based on hydrogen in the bus, we can eliminate this kind of pollution to the atmosphere. There are several methods available. Slide. This is the level of CO2 in the atmosphere. This 2020 report by the World Meteorological Organization. The CO2 level is almost 400 ppm, and this methane level is almost 2000 ppb parts per billion, and N2 also rising in a similar way. So these are all the reason for this pollution level, and also alarming situation. This recent report is very alarming for the entire, not only for India, but also for the entire globe. But because of this, there are natural disasters, cyclone, flood, drought, forest fire, cold, ice melt. These are all the things. I will tell you some of the example for this kind of natural calamity due to this climate change. Tropical cyclone and hurricane in 2016, heavy damage, and September 2016, not and Hurricane Maria in 2019, Idaya. It's a heavy damage to the life as well as property. In addition to that, flood situation in India, Japan, Kerala recently. Yeah, 2018, so 1.1 million people were displaced, and many people died. And so these are all the effect of this global warming because of the pollution emitted by the non-fossil fuel, fossil fuel. So these are all the effect of this natural calamity. And if you see the forest fire, Indonesia 2015, very huge damage, and Australia, Greece, California. In recent times, this is around 2018, this is also 2018. We haven't seen the newspaper. All due to this climate change because of non-green energy sources. These are some of the examples I'm giving you. It's taking so much time to change the slide. Bear with me, I don't know why. So that is why we are going for this green fuel, that is hydrogen. So hydrogen can be generated many ways from the coal gasification, ethanol, and the forest mass, other oil gasification, coal gasification. These are all the methods available for hydrogen generation. All these things will create small amount of carbon footprint to the atmosphere. That is why we resort ourselves to generation of hydrogen for green way, that is through water splitting reaction. Water splitting reaction is not changing. The Vijay Krishna sir, why is slide is not changing?
Yes, sir. Hello?
Slide is not changing.
Oh, 1 second, sir. 1 second. I will check it out.
No.
Hey, you are an already co-host, sir. You have a right to change the slide.
Hello? Sorry.
Yes, sir. You are already in co-host position. No problem to change the slide, sir.
Okay.
Yeah.
So some of the heat waves in India and Pakistan, because of the heat wave, there is a more than 2,000 people died in India and Pakistan. In Europe also heavy death due to heat waves. These are all the effect of this. Again, I am facing the same problem. Vijay Krishna sir. Hello? Hello,
Yes, sir.
slide is not changing. What's the problem? I don't know.
Oh, everything is good, sir. Here.
Slide, I'm not able to change. Oh, okay, now it's changing. Okay.
Okay.
Okay. So regarding the pollution risk, and in between some entering waiting room for this is also disturbing. Okay. Recently, IPCC, Indian International Panel on Climate Change, report 20 most polluted city in the world. If you see the picture, I mean data, 15 cities belongs to India. That too close to our capital, Delhi, Gurugram, Ghaziabad, for example. So it is very alarming situation. The rest five is also our neighbors, Pakistan, Bangladesh. So our entire pollution is, I mean, Asia is biggest. That to India is most polluted. That to capital is heavily polluted. So these are all the reasons for this. Emission of CO2, methane, and N2. And if you see the temperature rise in India, if you see the record, I mean, Rajasthan record of 50 degrees C. Gujarat, I mean, 45, 43 C in Gujarat, and Rajasthan 50 degree. Other places, even Jammu and Kashmir, 40 to 47. So this is called India fever. Heavy, I mean, temperature rise in the summer. Due to that, there's almost 2,500 people died because of this heat wave in India and Pakistan. So these are all the reasons for this global warming situation. So we're going for hydrogen generation to mitigate this kind of effect global, I mean, pollution level as well as the rise of temperature in the atmosphere. So hydrogen is a way for future fuel for our next generation, because the calorific value is more compared to other fuel on additional reason. 141 megajoule per kg, and to compare with the natural gas, diesel, gasoline, kerosene, LPG, LNG, almost very less compared to 141 is fuel number. It's almost 1/3 of this other fossil fuel based energy system. So in order to generate hydrogen, there are many methods available. Algae fermentation, gas, oil, coal gasification, pyrolysis of food, and alcohol also we can, from alcohol also we can extract ethanol hydrogen. But again, we have to spoil our pulses for creating this other system will give small amount of carbon footprint to the society. That is also not advisable to generate hydrogen from this kind of sources. So that is why we concentrating on this green way of generating hydrogen using solar, wind, and other geothermal electricity to generate hydrogen from water splitting reaction. Water splitting reaction is not a new thing. It is occurring naturally. If you see the plant, it is splitting water into hydrogen and letting out oxygen for our breathing. Using that hydrogen, it's not letting out hydrogen, it's letting out oxygen. If it is a plant is letting out hydrogen, we can somehow catch and we can use it for our energy purpose. But unfortunately, this hydrogen is utilized by the plant to prepare sugar, food for the plant as well as for the human being and other living species. So we are just mimicking the natural photosynthesis in our laboratory to generate hydrogen from the water. Plant is splitting water to prepare food, but we try to split water artificially for our comfort. When we have to go by car means we need fuel. So this is comfort, but this is main thing. Preparing food is main thing. The next natural photosynthesis is for preparation of food. The artificial photosynthesis is not preparation of food. It is mainly used for comfort. That is why we are more read about this comfort. So there are two ways to carry out artificial photosynthesis. One is photovoltaic electrolyte semiconductor interface. The semiconductor is in between conductor and insulator. If you have two semiconductor electrode, photoanodes, photocathodes, there are several materials, and put it in water and exposed to sunlight. It harnesses the sunlight photons and split the water and hydrogen also. But the efficiency is very, very less. That is why people are trying to improve the efficiency. Actually, people are getting only 1 to 2%. 2% is maximum level. Try to improve the efficiency so that we can easily get hydrogen. Just take water, the beaker, expose sunlight, you get hydrogen, and you can use the hydrogen for energy purpose. But efficiency is less. That is why we are going for another way of indirect way of generating hydrogen. That is photovoltaic. From the photovoltaic, we can convert photons to electricity. From the electricity, we can split the water. I think the slide is not changing. Sir?
Yes, sir.
Slide is not changing.
So I don't know. Maybe problem will be there. I think so.
Okay. Maybe correct. This is the photovoltaic device. From the electricity is generated. From the electricity, we can generate hydrogen. So all together, this is the system. This is natural. These things are artificial. So we are concentrating on artificial this photovoltaic system as well as photoelectrochemical way of generating hydrogen compared to the natural comparatively. Just we are mimicking the natural photosynthesis. This is artificial, mimicking the natural process to generate hydrogen. So hydrogen generation can be classified two ways: electrochemical, photoelectrochemical method. Separation of oxygen is a great difficult process, and oxygen reduction is used for generating electricity, that is fuel cell. So oxygen evolution and oxygen reduction is the difficult process. That is why we call it as electrochemical oxygen technology instead of hydrogen technology. Because oxygen evolution is once we evolve oxygen, automatically hydrogen will be evolved. So once you reduce oxygen to water, automatically you get electricity. That is why we call it as electrochemical oxygen technology instead of electrochemical hydrogen technology. Because we focus on difficult process as a main thing for this. In water electrolysis, I don't know what the slide is not changing again. Water electrolysis is based on this several techniques. Several methods. That is based on electrolyte or temperature. If you use alkaline based alkaline water electrolysis, if you use seawater with seawater electrolysis, if you use high temperature electrolysis, SO is solid oxide electrolytic cell at 1000 degrees C. Again, slide is not changing. What is the problem? So, what can be done, sir?
I don't. Yes, sir. It's not changing, sir.
Not changing. And in between, this is coming. This is entry admit. I am giving you admit also.
Yes.
Okay.
Yes.
Now it is changing.
Yeah,
okay,
maybe there is a late response.
Okay. So water splitting, the theoretical requirement in terms of temperature requirement to water splitting, you require about 2000 degrees C to split water for hydrogen oxygen. But evaporation of water is only 100 degrees C. That is, water is converted to vapor. That is 100 degrees. But if you want to split, you need a 2000 degrees. It's very difficult to get a huge high temperature to split water. That is why you're going for this electrochemical. But electrochemically, you need only theoretically thermal potential 1.23, thermal voltage 1.48 volts. Just battery 1.5 battery is theoretically that voltage is sufficient to split water. But in actual practice, always a more voltage above theoretical voltage is required to carry out this reaction. So if you want to reduce the thermodynamic potential to the lower level, the external thermal energy can be supplied. That is called endothermic reaction. Electrochemically, if you want to operate above over voltage, the excess over voltage will be dissipated as it is an exothermic reaction. If you want to operate endothermically to reduce the voltage, you have to supply heat energy from the surroundings, so that you can reduce the theoretical potential to the lower level above one or below that. This is the reason where we cannot split the water into hydrogen and oxygen. It's such a simple system. 1.5 to voltage sufficient to split water. How efficiently we are splitting, how we can make it economically viable technology is the challenge. in SICRI, actually, the rate as the rate response slide is not changing. Let us wait for some time. So in SICRI, we are concentrating on preparation of this catalyst and interfacing catalyst with the memory to optimize certain things to get a maximum efficiency, to get a economically, globally competitive hydrogen generation for energy purpose. Okay. This is the as I explained in the previous meeting, water electrolysis on the anode side, we are first hydrogen, we are getting oxygen on the anode side, proton transport to membrane and get reduced at the cathode side to get hydrogen. So all this parameter I explained previously, I don't want to explain. If you have any query, you can ask me in the end of this. So bigger particle also we can prepare, and by having this some specific kind of surfactant, we can prepare small catalyst, small particle size. So we compare this particle size effect for hydrogen generation. This is the response of this small particle. This is the bigger particle. So if you see the surface area is increasing by having small particle size, and accordingly we can get a less voltage. This red color, you see the hydrogen gas. This is the gas solution reaction. If we polarize the electron from equilibrium potential, we keep on increasing the potential. At particular point, there's a steep rise in current where the gas solution is taking place. So almost if you see the bigger particle and the smaller particle, you can see the 200 millivolt, 0.2 volt decreasing voltage. So one cell is 0.2 volt. If you have 100 cells, how much voltage we can reduce it, you can imagine. This is for, you may think that what is that 0.2 volt, 200 millivolt is very, very less. But for one cell, 200 millivolt, for if you have 100 cells, how many voltage we can reduce? So how many energy we can save? So that is how we are evaluating the performance of the catalyst and the whole system to make it efficient system for generating hydrogen. There, the role of electronics starts changing. The role of electronics is playing a major role in connection. So suppose if you have the connector also very good in order to connect. So what kind of material do you have to use to connect the pass switch with 1000 ampere or 500 ampere current to the battery system, and how we can interface the photovoltaic system to the electrolyzer. Maybe slide again, it's not changing.
Maybe slowly it can be response, I think.
Slowly because of the net connection problem over say, I don't know.
Yeah, maybe sir, it may be.
Yeah. So when you want to connect this electrolyzer to the PV system, you have to have DC-DC converter. You have to have stabilized current to the water electrolyzer. So in the case of water electrolyzer, we are using DC-DC step down converter. In the case of fuel cell, we have to have step up. So I will come to that point next. So we are having that power electronics tool to optimize the certain parameter in connect to the PV electrolyzer. Again, connect the electricity from the PV to the water electrolyzer. The water electrolyzer, there are so many things. Electronics, electrical, ionic conducting part, as I explained previously. Those things are very, very important. As I told in the previous meeting, through the electrochemical impedance spectroscopy, we can optimize the interface resistance and the ionic resistance, how ionic and the electronic interfaces are optimized through electrochemical impedance spectroscopy. It's not changing. Why? It's taking too long time.
Yes, sir. I think you have to close it and again reopen it, sir.
So I do that.
It will move, sir. I
Oh,
think it
okay.
started.
Okay. So based on that, we have assembled a cell and we have evaluated the cell at different temperatures. As I told you, when you supply some amount of heat from the surroundings, naturally we can reduce the electrical requirements. For example, we see this cell operated 1.9 or 2 volt, whereas there's a 80 degree, the electrical requirement is very, very minimal. We can operate at 1.8 volt. So if we have free electricity, solar heat is available, solar heater is available, we can reduce the electrical requirements. Some of the energy can be obtained from the solar thermal method. So that way also we can reduce the electrical requirement for this hydrogen generation. Initially, we are designed for our electrochemical reaction, 80 degree for our hydrogen generation. After that, we gone for higher level for electricity generation, hydrogen generation for industrial here. One not going to give 1,000 liter per hour. 1,000 liter per hour hydrogen can be generated. That is also connected to the power PV module. These are all the technology transferred to a company. So first alkaline system we transferred. After that, we are transferred compression, electrochemical compression. So hydrogen, some of the company require high pressure, 10 bar, 20 bar like that. So we can also compress. Mechanical compression is one way. Mechanically, we can compress any gas to a particular level. But electrochemically also we can compress. The method is available. Nobody, many of doesn't know how to compress hydrogen. Electrochemically, we need electrochemically compress the hydrogen to 10 bar, even 20, 100. We can go up to 10 bar according to the company requirements. There is a second technology. The third technology is the PEM technology. It is again the same problem. But we have advanced technology, and we have many installation in India, Mumbai, and abroad. Oman, we have installation for weather balloon launching. And regarding alkaline, the thermal power station and the metallurgical iron removal, steel industry, we have given many installation in India. So now our entire system is connected to the renewable energy, solar panel. So the cost is coming down on par with the international, global, US, United States Department of Energy, hydrogen generation, and our SICRI, and the energy generation, on par with the international global competition level. I have the graph I wanted to show you that the current efficiency.
Yes, I'll do it one thing, sir. You can send the mail to me, sir. Your PPT. I will change it here and.
Now it's changing.
Yeah. Okay, sir. Okay.
So this is our installation at Mumbai. This is Oman. So globally, we are competitive to meet the requirement of hydrogen generation. So coming to this electronic part, the basic requirement is design of power electronics for hydrogen generation, because we have to reduce the power losses in the interface, convert in order to obtain the highest possible energy efficiency for the electrolyzer. In the electrolyzer, actually, we require step-down DC-DC converter. There are many systems available. We have to choose a appropriate DC-DC converter for our energy efficient water electrolyzer system. Now coming to the photoelectric system, that is directly splitting water using semiconductor electrodes. The photoelectric water splitting reaction, the problem is very duality problem, because when they have a light absorber, it is not stable in water. If it is stable in water, it is not a good light absorber. So we have to have a optimized things to get maximum efficiency in photoelectric system. There are several semiconductors available, starting from TiO2, zinc oxide, iron oxide, silicon, titanium, copper oxide. So how we can optimize this? Because in the visible light, we have only 5% UV. The rest is visible region. The 400 to 800 nanometer is visible region. The 95% is visible region. Only 5% is UV region. So when you have band gap of 2 volt, when you have band gap of 2 volt or below above 2 to 5 below energy gap, we can efficiently split water into hydrogen and oxygen. At the same time, the material should be stable in water. Many of these semiconductors not stable in water. For example, if you take iron oxide, we cannot see the response for hours. It is a good light absorber, but it absorbs for only for few minutes. After that, it is not absorbing light. That means it's not stable in water. Whereas other system, for example, take a PeO2, is highly stable in water, whether it is acidic or alkaline, it is very stable. But the band gap is 3.2 or more. So it will absorb only UV region. But the visible light, natural sunlight, 98% is visible region. So we have to tune the band gap of titanium oxide, such a way that it will absorb only the visible region. So for that we did some modification in the TiO2 materials. We have doped nitrogen molecule. While preparing the TiO2 material, we prepared this TiO2 the form of tubes, nanotubes. So the tubes have size of 80 to 100 nanometer. So we can dope that titanium nanotube with the nitrogen, so that we can able to reduce the band gap from 3.2 to 2.7, and also it is stable in water in photoelectrochemical system for almost 150-120 hours stable. This is the first report. Such a huge stability in the natural sunlight. We measured natural sunlight. We generated hydrogen in the natural sunlight. You have to wait for some time to show the picture how we measured the hydrogen generation from photoelectrochemical system.
Okay, sir.
Maybe the network problem, I think. Otherwise.
Yeah, maybe, sir. Yes.
So that is what about this hydrogen generation from electrochemical photoelectrochemical. Now, coming here also, the power electronics play a major role, because this band gap tuning, tuning also, some kind of doping, and also we can measure the energy gap to optimize, to select the material. Now, how we can connect to the solar system? How we can reduce it? Because we are very small current in the photovoltaic system. How much the wires, how we can expose, those things are very important. So coming to that utilization part, how we can replace the hydrogen generated by the photovoltaic method. There are two ways to utilize hydrogen. One way is we can directly put it into existing IC engine. It's not advisable because hydrogen has huge calorific value. We cannot directly put it. The material, the temperature will go up. The material, the standard temperature, if you use hydrogen alone in the existing internal combustion engine. So now people are started using this hydrogen along with the petrol or diesel or natural gas, 10% to 20%, to reduce the emission level and increase the efficiency of this IC engine. Instead of using 100% hydrogen, mixing with the hydrogen. Another way is utilizing hydrogen is the fuel cell. Again, the fuel cell is a device which convert chemical free energy into electric energy. Any chemical reaction whose free energy negative can be used to run the fuel cell. So very simple system to generate electricity. So like water electrolyzer, here also we have membrane, and membrane, water catalyst on the anode side and the cathode side. So once you pass, yes, not able to show this slide. Wait for some time. Pass hydrogen on the one side, and oxygen getting from the other side. We don't need to have cylinders, oxygen cylinder for this fuel cell, because whatever the oxygen available, the plant is efficient. So naturally, gas that is called air breathing electrodes. Like we breathe, the fuel cell also breathe. We are breathing, naturally we are breathing. No? Naturally we are getting oxygen from the atmosphere, we are breathing. Like that, fuel cell also breathe. Once you pass hydrogen on the anode side, on the cathode side, the cathode the design such a way that so many pores and high surface area electrodes. It naturally, once you enter the hydrogen is entered, get oxidized, it naturally breathe the oxygen from the atmosphere. That is the beauty. You don't need to supply oxygen. That is called air breathing electrodes. So from the air breathing electrodes, we can pass the air to the cathode compartment. It breathes only oxygen. It will not take nitrogen. So it gives water and electricity for our energy generation. So it is so much long time.
So you please close the PPT and open it again, sir.
But shall I close and open it again?
Yeah.
Shall I put leave meeting and
Okay. Maybe a network problem, sir. Definitely.
network. Which side I don't know.
Yeah.
Sure. So shall I leave and again?
No, so only close that PPT itself. That's what you don't want to. You don't go leave, sir. Close the PPT and again open it. That's all.
Okay. Stop sharing. I have to put stop.
Yeah, yes, sir.
Now again go for
yes, sir.
Share screen.
And PPT also close the PPT and open it, sir.
Okay. I think old PPT also open. I think so. That is maybe the reason.
Yeah, maybe some formats will be different. I think your voice will be some other format. Windows will be some other.
Krishna?
Yes, sir.
Is there any audio problem, sir?
No, sir. Everything is fine, sir.
I am not unable to.
Yes, sir. Please put your phone on mute, sir.
Phone ledu in system. I am already in system, not phone.
Okay.
Okay. Now, is it okay?
Okay.
Slides are visible, sir. Slides.
No, sir. Please share this. Ravikumar, sir, please unmute yourself. Mute yourself. Yes, sir.
Now, what is the slide? You can able to see slide?
No, sir. Just click share your screen, sir. Yes, sir. It is visible.
Okay.
Yeah.
I'll go to full screen.
Yes, sir.
Now it is full screen, no?
Yes, sir. Yes.
Now it is moving.
Yeah. Yes, sir. Yes, sir.
We would have done that much.
Yes, sir. Yes.
Okay, now it is correct. I am comfortable. Yes. Okay.
Yeah, thank you.
Okay, now I will go to that.
Yes.
Okay, so I finished. Okay, I go to that. Okay, this whatever system also I finished. I think so. So these are all the So these are the tubes, nanotubes we prepared. Our pore size is 80 to 100 nanometer. We doped nitrogen in that nanotubes, and we can able to get hydrogen continuously for 120 hours by exposed to natural sunlight. If you see solar, all these things we measured outside. We also measured the light intensity meter, that is the lux meter, and this is current, this is a potential. We measured everything continuously in the open atmosphere. And we compared our result with the global scenario. These are all the previous report reported by many other universities, and our thing is 0.5%. STH means solar to hydrogen efficiency, 0.5%, and the stability is more, 120 hours. Without doping, we are not getting this kind of stability. If you see the previous report, only 20 hours, 2 minutes, 10 minutes. That is the problem of the semiconductor. That means directly splitting water into hydrogen oxygen. So people are trying to improve the stability and also the light absorbing property of this photocatalyst, either photon or photocathode. So in our system, we used mixed electrolyte and also the nitrogen doped TiO2 to increase the efficiency and also the lifetime. 120 hours continuously operate. Morning we start, we finish at 5:30. The second day also we do the same thing. This table up to 150 hours. We try to improve the further stability currently. So fuel cell, again I explained, is this is a device that converts chemical energy into electrical energy. Simple system is the polymer autorate because we operate at low temperature. Alkaline system is also low temperature, but handling of alkaline is more dangerous than acid because once you spill it on your hand, it is difficult to wash. That is why people are not going for this alkaline system because it's not user friendly. Whereas polymer is looks like a polythene paper, it is a compact design. There won't be any layman can operate this handling this polymer fuel cell. Phosphoric acid again is using acid, but it is temperature is slightly higher, but the spill of phosphoric acid is another problem. And the molten carbon fuel cell also same thing. It is operated very high temperature 650, and the ATS zirconia is also wonderful system, a very efficient system at high temperature. But this system, molten carbonate solid oxide fuel cell, can be utilized for generating electricity for power in the particular building. For isolated place, you want to power the hospital. For isolated place, you want to power the school, some community hall. For this, where wire cannot be connected. This system was very useful for such specific application things. Coming to the fuel cell, the hydrogen get oxidized and the protons generated, and the electricity is going to the circuit. The electrons going to the circuit, and the proton get reduced at the cathode using the oxygen present in the air. So, as I told you, we don't need to supply oxygen separately. Whatever available oxygen in the atmosphere is sufficient to run the fuel cell. That is the beauty of this electrochemical generation of electricity through the fuel cell. This is the simple system demonstrating you to understand how fuel cell works. So from the tanks, hydrogen tanks, we are supplying hydrogen, get oxidized, and the electron is going to power the bulb. For example, there is the electricity used for running the vehicle. And on the other side, we are getting the proton is converted into water and combined with the oxygen. So this is the current potential for the fuel cell. Theoretically also the same 1.23 volt theoretical potential for one single cell. And the losses can be classified 3 ways. The cell potential losses in the initial due to activation overpotential. Activation overpotential means the catalyst is not proper. It's a small dip in the OCV, open circuit potential, less potential. So the lack of catalyst, like the catalyst is not proper. You can see this kind of dip in the voltage. And ohmic losses. As I told you, the interface is not proper. Either it ionic or electronic. Interface is not proper. You can see the drop in this region. Mass transport losses, as I told you in the keynote address, if we stop hydrogen, or if the hydrogen is not entering the electron interface, you may see a sudden drop in voltage. So these are all the major problem in operating the fuel cell. Here only the electronics or power electronics playing a major role. To identify the losses or errors in the fuel cell when you put it in the real vehicle. So how we can go for this power electron application, the fuel cell powered vehicle, that is called e-mobility. So high efficient converter is essential requirement and the key parameter for the performance of the fuel cell in the real application side. Real application is the vehicle. So that we can reduce the size of the fuel cell, cost of the fuel cell, and we can increase the efficiency and reliability on the fuel cell system for mobility application. Therefore, selection of appropriate converter topology is an important parameter for the running of fuel cell in the real vehicle application. For example, if you take fuel cell, the theoretical voltage is only 1 volt. But when you start training current, when you take out current from the fuel cell voltage will come to either 0.3 to 0.5 volt. This is not sufficient to run a vehicle. Though we have stack, but the single cell will come to this 0.5 or 0.3 volt per cell. We may have 100 cells, then voltage will come to 50 volts. Something. So here compared to water electrolyzer, fuel cell operation with the power electrolyzer is very important, because DC converter we have to step up to the particular voltage through a DC converter, so that we can run the vehicle smoothly. Because all the time we cannot get same 0.5 volts. Sometimes there is a fluctuation in that fuel cell voltage because of the mass flow. As I told you, mass the hydrogen is not going. There is small level fluctuation in the voltage also. So in order to make constant voltage as some current, we need DC converter. Here we usually use step up DC converter. But with power DC converter, there are many problems. Which kind of power converter you have to use? Only you people has to answer. You people understand better than me. So these are all the problems existing for the electronics and the electrical people. When you connect the fuel cell or onboard electricity generator in the real vehicle situation. So these are all about the utilization and use of power electronics in the fuel cell application. So coming to the stationary application. Suppose if you want to have this electronics are mobility, and we can go to, if you have a fuel cell, it doesn't work, there's a problem in electronics, we can go to workshop and we can, the electronic people, we can somehow repair the electronic components. But if you want to power telecom towers now running on this diesel generator. If you put fuel cell for this powering the telecom towers, the remote side, if you fix fuel cell, generate electricity, or we can control where it went wrong, where the errors occurs. That can be done through this Internet of Things, playing a major role. So we fix sensors and other control system in the fuel cell station at the telecom towers. So through that internet, we can get the data. If there is errors, we can correct from the particular site. That is Internet of Things playing a major role. Now, India almost 100 telecom towers are powered by this fuel cell, and everything is controlled by the Internet of Things. So again, it is coming
again same problem.
Anyway, it is close to conclusion. So I will somehow finish with without PowerPoint. So Internet of Things, it's not a single component; it's an embedded system of many components. So each sensor has to be installed in a particular place, and the sensor has to be controlled through the internet. if there is a problem, we can, some of the things we can control through internet, but some of the things we have to change physically. That can be monitored through the IoT system. For example, if hydrogen gas is not there or methanol is not there in the site, we can tell the vendors to supply hydrogen or supply methanol to the particular telecom towers, so that continuously we can get electricity. So that is the advantage of IoT, to operate the fuel cell at remote site. But normal site, no problem. If cities, no problem, because we have electricity power supply through wires. So operating that telecom towers in the cities is not a problem. But the remote site, where people cannot enter, the hillside or the desert site, it's very difficult to reach by vehicle or something like that. Where we can arrange local people to supply the fuel, either hydrogen or methanol to particular site. So that can be monitored. We have to give instructions to the vendors to supply the gas, hydrogen gas or methanol. So this IoT system is very, 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 very useful for operating the fuel cell at remote site. But vehicle is not, IoT system is not recognized. But in vehicle also, people are now installing this IoT things in the vehicle also. Though the fuel cells vendors is monitoring the fuel cell in the high speed, low speed, how it performs. Those details are driver cannot record, or as a passenger you cannot record all those details. So remotely they will collect the data. When the fuel cell is put it on the vehicle, when you go at high speed, how it performs. When you go at slow speed, how it performs. So where the problem is occurring, those things can be monitored through the IoT system, so that we can efficiently modify the electronic system or the fuel cell system. Those data can be collected to Internet of Things. I have slides to show you, but it's not changing. Anyway, okay, I will manage without the slide. So these are all the systems, power electronic system, the IoT systems I explained to you, is playing a major role when you want to implement the e-mobility in the country. So not only chemists, electronics will play a major role in implementing, in experiencing the fuel cell powered vehicle in the future for our next generation. So coming to the global scenario, Iceland is the first country to implement this hydrogen fuel cell vehicle, because Iceland has huge amount of geothermal energy. From the geothermal, they generate electricity. From the electricity, they generate hydrogen. The first country in the globe to implement hydrogen economy. Second thing is the Germany is producing huge amount of hydrogen from Saudi Arabia and shipping to the home country, and many installation, hydrogen filling installation throughout the country. 150 hydrogen filling station. So they are running vehicles on that. Third position is Japan is I mean the 2020. 2020. What is that? Game, Olympic game. They plan to use all vehicle powered by fuel cell. That is the plan. The program itself is changed due to Corona virus. Olympic 2020 Olympic, they plan no diesel or petrol vehicle. They plan to have a fuel cell vehicle in the complete transportation. Spokesperson to the particular place, and all transport they plan such a way that all vehicle powered by fuel cell. But unfortunately, due to Corona, the entire program, the Olympic itself is changed to next year. So that kind of emergency is there. So that will popularize. Because huge people assemble at one place. If you see the fuel cell powered vehicle without any noise, without any pollution, so it gives some kind of popularity and awareness to the people. So we can easily implement the fuel cell system, fuel cell system, the electric mobility, so that the bus is running without any noise, without any emission. You see how it looks like. So that is the idea. Japanese people plan to implement this fuel cell powered vehicle for the Olympic 2020. Okay, anyway, next Olympic, we can see the same kind of impact. So that's all about this. The power, the role of power electronics and IoT system for implementing this fuel cell powered vehicle. In India, I mentioned all countries. In India, Tata Motors already have 10 buses running on this fuel cell powered vehicle. Cities Mumbai, Pune, Bangalore on best basis. Apart from that, another Mahindra also going assembling this fuel powered vehicle or battery vehicle. I don't know exactly. E-mobility is going to experience soon. Our next generation will experience the pollution-free vehicle through hydrogen. Yes, that is the message I like to convey to the electronics people, EEE people, because your role is very, very important. In addition to chemistry knowledge, electronic knowledge is also very, very important for implementation of this fuel cell powered vehicle or e-mobility vehicle in that country. So, anyways, slide is not moving. So, with this, I think I can conclude. If there are any questions, I am happy to answer your question. Thank you, Ananda.
Yes, sir. So participants, is anybody have any questions? Participants, you make sure to ask any questions, no problem. Or you can post it in your chat box also. Related to any question, it may be chemical, that is not a problem.
No, it is changing.
Yes, yes, yes.
Okay, number of slides are more. That's why this type of problem may occur, sir.
But last time also I had almost.
Actually, how many slides are this?
This almost 60 slide, I think.
Okay, maximum 30 slides. It's okay, sir. It move faster. Otherwise, it may take a lot of time to review or connect.
Okay.
This is 60 slides means the memory it may be more than 15 MB, I think so.
Okay.
That's why this type of problem may occurs online platforms, sir.
Okay.
Not only Zoom, anything. Anything. Suppose if I want to present anything like this, this must be maybe less than 30 slides. That should be less than 5 MB. It may be move faster. Otherwise, it may be in middle. It will struck.
Okay, sir. Thank you for your suggestion, sir.
Thank you very much, sir.
You are electronics, you know. You are giving correct. I didn't know. When I purpose next time.
That is bandwidth problem will occur, sir. That is.
Okay. That is, I heard that many people told better to move to video.
Otherwise, 60 slides can be divided into 3 parts, sir. After completion of first part, then you can add second part like that. Then our presentation will go smoothly, sir.
Okay. So we can switch over to our next presentation. That is 3 files.
Okay, sir.
Yeah, participant, have any questions?
Even if you have any question, you can ask me. Even if at later stage, if you have any question, you can send a mail to me. I'm happy to send the reply through email also.
Yes, sir. Participants, if you don't have any questions, shall we conclude the session? Yes. So with this, I conclude the session. So thank you, sir. Thank you very much. Once again, I really very glad, sir. Really, we have this session. It's really what you convey is really very, very nice, sir. You cover all the things while coming the way of your interconnecting that chemical to that electricity and then electronics. It's really good, sir. Thank you very much, sir. Accepting for an invitation also and disturbing so many times also.
No, sir.
Yeah.
Anyway, I am also happy.
Yes, sir.
Very glad because you people are showing interest to know the new things and I am getting knowledge from the electronics people. So I am also very happy instead of interacting with the same chemistry people. But
Yes, sir.
you are now some is selling now. So
Yes,
if
sir.
if you reduce the slides, we can easily or split into 3 parts and easily you can.
Yes, sir.
It is it's only sharing of knowledge. Some knowledge
Yes.
you have, some. I'm not telling I'm not great thing. So you
Yes, sir.
have your own expertise. I have my own expertise. So combining these things will be the option. I mean, the best option to integrate and implement any technology. Hello.
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 Vijay Krishna. Vijay Krishna. Even the candidate came. What happened?
Yes, sir.
Okay. Speak something.
Yes, sir. Maybe sir mic will be muted.
No, sir. Sir is talking, na?
Yes. Okay.
Yes. Thank you, sir. Thank you really.
Okay.
Thank you very much, sir.
Okay. I'm also thank you all the participants and also the HOD and your contribution and other people who are I don't know the name except I would like to thank all people showing so much enthusiasm to gain the knowledge, fields of knowledge and hydrogen possibilities. Thank you so much.
Yes.
Thank you, sir. Thank you very much, sir.
Thank you.
Participant, please give the feedback which will be available in the chat box and comment boxes. Thank you.
Sir, I answered the question. It came in the chat box now. Hello, Vijay sir.
So tell me, sir.
Some of the questions raised by participants. Shall I answer?
Yeah, you can answer, sir. No problem.
Some participants raise which fuel cell is best. So for stationary application, that molten carbonate, solid oxide fuel cell best for stationary application. For mobility purpose, for vehicle mobility, PEM based, low temperature based system is best for e-mobility application. For stationary, high temperature, solid oxide, molten carbonate is suitable. So depending on the application, we have to choose a fuel cell. Are you hearing?
Yes, sir. Hearing, sir.
Okay.
So, is there any questions, participants? I think. Yes, sir.
Somebody is asking, no? Thank you. So, what is the application of proton exchange membrane fuel cells? Okay.
Yes, sir.
Proton exchange membrane fuel cell application mainly for this electric mobility, not for stationary application. Other fuel cell system, for example, molten carbonate and solid oxide fuel cell for stationary application. The other question, exchange membrane fuel cells are fiber fuel cells. Okay, this question is answered.
Yes.
Okay. Nalini Devi, thank you so much. Okay. Another takeaway from what is most
the application of portion exchange membranes fuel cells?
Pardon?
What is the applications of portion exchange membranes fuel
cells? Proton cell application mainly for this electric mobility. Mainly for electric mobility.
Yes, sir.
Not for stationary application. For stationary application, solid oxide fuel cell is the preferred fuel cell system.
Yes.
For the proton exchange membrane fuel cell is a low temperature operated low temperature, which is mainly for e-mobility. It is instead of using battery, we can have this on-site electricity generation. This is only for mainly e-mobility.
Yes, sir. The next question, sir. So is it usual for
Yeah,
laptop?
somebody asked laptop, PMM laptop also. Proton exchange and fuel cell can be used for laptop also. No problem.
Yes, sir.
Laptop also we can use that.
Okay. Which type of fuel cell is most preferable? Yeah.
But
Which type of fuel cell is most preferable?
it depends the application. For example, if you want to have stationary applications, suppose if you want to power some small hospitals, school, elementary school in the remote side, for that purpose, high temperature fuel cell, solid oxide fuel cell, motor carbon is preferred one. For mobility purpose, for moving the vehicle, solid oxide fuel cell is preferred one.
Yes, sir. I think that's all, sir.
No.
Yeah.
Okay, if you have any question, you can post me. You can send a mail to me also. No problem. I can answer anytime. You can send a mail to me. I can clarify the question.
Yeah, definitely, sir. Yeah. Thank you, sir. Thank you.
Thank you.
Thank you.
విజయకృష్ణ, హలో విజయకృష్ణ ఉన్నావా?
సార్ ఉన్నాను సార్.
ఒకసారి నువ్వు ఫోన్ చేయ గురు, నాకు అర్జెంట్ పని ఉంది.
క్లోజ్ చేస్తున్నాను.
అర్జెంట్.
Sir, shall I leave or? Hello, Vijay Krishna sir. Hello. 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 Hello, sir. Hello. Hello, sir. Shall I leave? Oh. Thanks.
ఇప్పుడే 12:30 అయిపోయింది. టైం గురించి కాదు, ప్రిన్సిపల్ ఒకసారి కింద ఇట్లా అటెండర్ బయట కూర్చున్నారు, అసలు రాలేదన్నాడా?